All right, so this is the screencast of the PowerPoint on minerals. It does start with a quiz. We're not going to cover that here, but as you go through it on Blackboard, you'll see that the quiz is over the first 3 slides. On the stuff that we covered before the break and the shift to online instruction, you should go over those questions. All right, so I'm going to jump to minerals. So we had already looked at sedimentary rocks, and so we covered kind of some of the differences between minerals and rocks. But just to reiterate that a mineral fits a couple criteria. One, it's naturally occurring, it's inorganic, and third, it's a solid, as opposed to a rock, which is an assemblage of multiple minerals. We looked at a picture similar to this last time we met, and something like this granite here is easy to pick out the different colors. Each of those a different mineral, which is listed at the top here. And so some of these you'll become a little bit more familiar with. Obviously, we don't have access to the samples here, so we're going to do the best that we can and kind of lean on the textbook, other web resources, and then the Gizmo assignment for the lab for this. All right, so normally what we would do is try to use a series of tests to identify what the mineral is. So I want to have you go through these tests, and you'll do that in the Gizmo, really to learn the different characteristics that are listed here on the left of this mineral identification chart. So there are some ways to break it down that I think make a lot of sense. A lot of them do start with whether it's a metallic or non-metallic luster, and then from there break it down. I will say that in practice, this can be rather difficult. It seems like you would end up with one, definitive answer here at the bottom, but it's still a little bit subjective, and so I find that with students, this is actually a little bit more difficult than it would sound. So again, in the Gizmo that you'll be doing, you'll go through each of these, but just to sort of give you an overview of them, a couple of things. The primary one is the Mohs hardness scale. So this is a series of tests that we do where we compare the mineral to another material that we know the hardness of. And basically we're trying to say, does the mineral scratch that object, or does that object scratch the mineral? Okay, to try to figure out how hard it is. That generates a number between 1 and 10. So that's one of the tests we can do. The second is the density or specific gravity. So you're probably familiar with that. The Gizmo has you do that as well. Color works. Some of these have minerals have unique colors. Others come in multiple different colors. So sometimes it's helpful, sometimes it's not. All right, so the Mohs hardness scale, there's different versions of it. They all kind of generally look like this. Some of the numbers might vary. Basically, you want to start with the material and work your way up. And so the first thing you would do is scratch it with your fingernail. And so one of two things would happen there, right? Either your fingernail is going to scratch the mineral, or the mineral is going to scratch your fingernail. So you don't want the latter. You would want to, gently kind of scrape at it and see if your fingernail is chipping off pieces of the mineral. If it does, that means that the mineral is harder than your fingernail. So then you go on to the copper penny, right? So we know the hardness of a copper penny. It's about 3.5. So if the copper penny scratches it, we know that it's about that hardness. And then just sort of work your way up until you get into, steel. There's a point where you're probably going to, for some of these, not be able to scratch. And so, again, we're going to not do this in practice, but rely on the Gizmo to do this to try to generate a number. And sometimes it's a range, and it's going to vary a little bit from sample to sample. Some of the other properties that we do is we look at the powdered form of the mineral using a streak plate, which is basically just a porcelain plate that we take the mineral and run it across. And sometimes the mineral has a different powder color than it has the actual color that we're looking at, and that can be helpful. For minerals like graphite, the same graphite that we use in pencils, it's pretty obvious. That's a good little test there to figure out what graphite is. And then luster, as we'll look at here in the next slide or two, lots of different terms for luster. Tend to stick to just using a few of those. And then, as with with anything, this other properties, really those things that make the mineral stand out. Now, again, this would be a lot better if we had the samples in our hands. But an example for that would be sulfur. Right, so nothing is going to look sort of the same as sulfur, and so that's the other characteristics. All right, so in terms of luster, metallic and non-metallic are the two main categories, right? So does it look like a metal or does it not look like a metal? All right, so does it look like aluminum? Does it look like copper? Does it look like steel? If so, does it look like gold? It would be a metallic. If it doesn't, then it fits into non-metallic, and you can see here that there's a lot of different terms for this, and even more up here in the image to the left. They're a little subjective. Try to use them. What's the difference between glassy and waxy? It gets a little bit subjective, and so that main category of metallic and non-metallic is probably the best way to think about those. If you can try to use some of these other descriptive terms, that may be helpful. Okay. All right, and then some of the minerals just sort of have these natural faces, or what's sometimes called these sort of habits. And you can kind of count these things. I don't know that the PowerPoint gets, or the Gizmo gets into that. It does ask you to look at the shape, I think. And so something like pyrite and galena, they form these nice cubes, which I think I have another slide in here later on, just to remind me. When we see these nice kind of shapes in these crystal shapes, and that's really what these are. These minerals are an assemblage of different elements that bond together, right? And so when they do that, if there's enough room for them to form these nice bonds, they will form these shapes. If there's not enough room for them to grow, then you get something that doesn't look quite like this. And I've got I think the last slide has that on it. All right, so this is just a reminder of sort of why that was going to look like cubical, in this case, salt. So we have the NaCl. The way that those are bonding together causes these right angles to form, and therefore when we look at the salt crystals, they form as cubes. All right, the other property that you can look at is whether there is a cleavage plane or not. And so cleavage means if it was to break apart, imagine if you were to take your book and try to break it into pieces. Between the pages themselves, it would cleave nice, right? Those are a nice way to sort of cut through it. If you were to try to rip across the pages, it would fracture. It wouldn't leave a nice cut, so to speak. And so that's really the difference between cleavage, as you can see the images on the left, result in these nice planes that break across. The next image on the next slide is probably the best one to look at. Cleavage. Fracture, there's really no smooth side to it. It just kind of breaks along no clear sort of pathway. All right, so this is an example of mica. Again, we have mica in a lot of rocks around here, so you're probably familiar with it. It flakes off into these little pieces that if you go into the woods and walk along a trail, it probably ends up in your shoes as little kind of sparkly, glassy, shiny pieces. So this is breaking it on a clear plane right here, clear cleavage plane. It's almost like pulling, again, pieces of paper off one another. Excuse me. And so, one of the ways that we can kind of look at things is how many cleavage planes there are, and whether what the angle is of them. That's probably going to be a lot more difficult to do without samples, so I'm not going to spend much time on that at all. Other than to say that the reason that those are breaking apart, especially that mica that we just looked at, is again because of these bonds. That's where the weak layer is, and so you can literally pull these apart because what you're doing is pulling that weak bond apart, and the actual sort of pieces that stick together form this layer at the top and bottom here. These what they call sandwiches off to the right, and those are more strongly bonded together. The next slide sort of shows these different angles that these bonds form at and therefore break at. And so that's one of the things that you can look at. Again, you can kind of see that in the Gizmo, but if you have the hand samples, you can see that some of these form cubes at 90 degrees and others are offset, like it says here, at 120 and 60 degrees. All right, so the last slide is that slide that I was talking about. It really is just a reminder that the image on the left, that's a nice crystal that grows when there is enough room for it to grow. In the presentation on igneous rocks, we'll talk a little bit more about crystals and that growth of crystals and the size of crystals. But the image on the left is a crystal that's had room to grow, it forms these nice shapes that you see here. The one on the right, same mineral, quartz, just didn't have the room to grow, and so it doesn't have that nice sort of crystal shape that you see on the one to the left. All right, so that's the short nitty-gritty on minerals. Again, the assignment that goes along with this is the gizmo on mineral identification that is under the course folder on the explorelearning.com page. And so I'll direct you over there. And a reminder, you can log on with my logon, which is R. Herman, and the password is Gizmo. All right.